All right, today we're going to go over gas law problems, where it goes over where you have to convert your units into the proper units necessary for the formula. So we're going to practice conversions first. The first conversion is going from grams to moles. So our conversion factor is going to be the molar mass. So 1 mole of sulfur dioxide is equal to, I think it's 64.07 grams of SO2. So I would start with my 52 grams of SO2. And we know that 64.07 grams of SO2 is to 1 mole of SO2. Divide the two, and you get 0.812 sig figs, because I started with 52 grams, moles of SO2. When I'm converting millimeters of mercury to atmospheres, I'm going to use the conversion factor. 1 atmosphere equals 760 millimeters of mercury. Start with my 521 millimeters of mercury, multiply by my conversion factor, 1 atmosphere, so 521 divided by 760, 0.686 millimeters of mercury. That's my answer. And then here I want to convert from milliliters to liters. Now, milliliters, one way you can remember is we did the King Henry died by drinking chocolate milk. So liters is your base. So that's going to be 1. We move 3 times. This is a base 10. So for every jump I make, it's going to be a multiple of 10. So milliliters is down here. I did 3 jumps, so it'd be 1,000 milliliters. So we now know that 1 liter equals 1,000 milliliters. So if I start with 30.0 milliliters, I can use my conversion factor here to convert to liters. So this is going to be 0.0300. I need 3 sig figs because I started with 3 sig figs. Liters. All right. So knowing how to do these conversions will be important when we solve these gas law problems. The reason why we need to convert is because each combined gas law as well as ideal gas law require specific units. So in the combined gas law, which is P1 times V1 over T1 equals P2 times V2 over T2. The only units that are required are temperature. Temperature always has to be in Kelvin. But in the combined gas law, as long as our units match in terms of pressure and volume, that's the requirement when it comes to the units. So for example, if in pressure I have atmosphere, I have to have atmospheres for P2. But in the same way, if I have, say, millimeters of mercury, then my P2 has to be millimeters of mercury. So they just have to match each other, the pressure and the volume in combined gas laws. So, for example, if I have cubic centimeters, I need to have cubic centimeters for my second volume. The ideal gas law, though, is more specific. So the ideal gas law requires you to actually have specific units based off of the R value that you use, or the R constant that you use. So for example, if I use the R constant of 0.0821, the units are atmospheres times liter over Kelvin times mole. So therefore, my pressure, volume, number of moles, and temperature, my pressure has to be in atmospheres. Why? Because you see atmospheres in your R value. My volume has to be in liters, my N has to be in moles, and my temperature has to be in Kelvin. But what about if we use the other R value? So the other R value is R equals 0.831 kilopascals times liter over Kelvin times mole. In that case, it's going to be a little different. Your pressure, volume, N value, and your temperature. So if we look here, it should be in kilopascals, your volume should be in liters, your N value should be in moles, and your T should be in Kelvin. So, for example, if in an ideal gas law, I'm giving milliliters, well, milliliters is no good. I have to convert them to liters, right? So, or for example, if I'm giving grams doesn't work. I have to convert it to moles. So there's conversions that are required for the ideal gas law so that it'll fit with the R value you want to use. So let's do an example. This example requires me to use the ideal gas law. Why? Because we have moles. So I'm going to use PV equals nRT. Let's go ahead and my pressure is 755 millimeters of mercury. The volume is 125 liters. The N value, the moles, is what I want to figure out, and the temperature is 20 degrees Celsius. So hopefully you'll notice that there are two things I need to change. First is the pressure. The pressure is in millimeters of mercury. However, the R values that I use, I need my pressure to be either in kilopascals or atmospheres. So I'm going to change it to atmospheres. It doesn't matter. You can change to kilopascals. To do that, I'm just going to multiply by conversion factor. Remember, 760 millimeters of mercury is equal to 1 atmosphere. So I take 755, divide that by 760, and I get 0.993 atmospheres. I also have to change my degrees Celsius to Kelvin like normal. Alright, so now I'm good to go. My units are the ones I want. I have atmospheres, I have liters, and I have Kelvin. So I'm ready to plug it in. 0.993 times 125 equals N 0.821. Oh, I'm going to run out of space. 0.0821, and I'm going to throw up here 293. That's just all multiplied together, okay? And so what I'll get is 0.993 times 125, and divide that. Oops. Divide by 293. So my moles, no, I got like 5.16, but since 20 degrees has 1 sig fig, I'm just going to round my answer to 5 moles. So that has 1 sig fig. Okay. Let's try another example. So in this example, since I'm changing my volume, there's no mention of moles. I'm going to be using the combined gas law. So let's go ahead and identify all our variables. Oops. So here we have the volume to be 2,300 milliliters. This volume to be 400.0 liters. The temperature is 25 degrees Celsius. We want to figure out the other temperature. So notice pressure is missing, so we can just remove it. So in this case, pressure remains constant, so it's not something that affects the outcome. And so what I want you to notice is that when the combined gas law, pressure and volume have to have the same units. But here we see that V1 is in milliliters, but V2 is in liters. And so we have to convert one to either V1 back to liters or V2 to milliliters. It doesn't matter as long as they match. I'm just going to convert my 2,300 milliliters to liters. So you get 1,000 mils over 1 liter. This will equal 2.3 liters. So I'm going to use this number here now to match that liters. Always change your temperature to Kelvin, so you get 298. So now I have V1 over T1 equals V2 over T2. So V1 is 2.3 liters, T1 is 298, V2 we don't know, T2 is, V2 we do know. V2 is 400 liters, and then T2 we don't know. So cross multiply, you get 2.3 times T2 equals 400 times 298, right? So 298 times 400 divided by 2.3. So rounded to 2 sig figs, because 25 degrees has 2 sig figs, T2 is going to be 52,000 Kelvin. Alright, let's go to the last one. So in this case, it mentions you have grams, which could be used as moles. You have 33 degrees Celsius temperature. You have a pressure. You want to calculate the volume. The way I know this is ideal gas law is notice that there's no second temperature or second volume, or second pressure. So it's not as though something is changing. It's just you're taking a snapshot at that particular moment. And so we're going to use the PV equals nRT. So you got pressure, volume, number of moles, and temperature. So the pressure is given to you at 748 millimeters of mercury. The volume is what you want to calculate. The number of moles, there's no moles here, but what they do give you is it's 47.8 grams of helium. And then the temperature is 33 degrees Celsius. So if you notice, each one of these I actually have to convert. My pressure I'm going to convert to atmospheres by divided by 760 millimeters of mercury. 748 divided by 760 gives me 0.984 ATM. The number of moles I have in grams, so I can actually convert to moles. I know that 1 mole of helium, according to the periodic table, weighs 4.00 grams. So if I take 47.8 and divide that by 4, I get about 12.0 moles of He. I round it piece of sig figs, and then I need to add 273 to my Celsius, which will give me 306 Kelvin. All right. Hey, I got atmospheres, I got moles, and I got Kelvin, so I'm good to go. So let's go ahead and plug this in. So my pressure is 0.984. My volume I want to figure out. My N is 12.0. Since I'm in atmospheres, I'm going to use 0.0821, and then 306 is my temperature in Kelvin. If I solve that, I get about 306 liters, but I need 2 sig figs. Why? Because 33 degrees Celsius says 2, so this will give me 310 liters. So my suggestion is to do some practice. The more you do, the easier it becomes. There's some easy problems, and then there's some medium, so you want to be able to do some of those medium problems, and then there's a challenge problem at the end for you to try.